Welcome to the webinar X-ray Inspection, More Than Just Foreign Body Detection. Since the early 1990s, food and pharmaceutical manufacturers across the globe have relied on X-ray technology to detect physical contaminants, such as glass and metal, in order to protect the welfare of consumers and uphold brand reputations. However, X-ray inspection is capable of doing so much more. This webinar looks at how, in a single pass and at high-line speeds, X-ray systems can help avoid product recalls and customer disappointments by solving a wide range of product safety and quality control issues typically found within food and pharmaceutical manufacturing. It begins by exploring why X-rays are used to inspect products before explaining how X-rays are capable of seeing what we can't see. It then moves on to look at the ability of X-ray inspection systems to simultaneously measure product length, width, area, and volume, identify missing and damaged items, check for inserts, measure mass, monitor fill levels, and inspect the integrity of seals. Why are X-rays used to inspect products? Although there are no legal requirements for manufacturers to use X-ray inspection, guidelines such as Hazard Analysis and Critical Control Points, HACCP, the Global Food Safety Initiative, GFSI, and Good Manufacturing Practice, GMP, as well as ad hoc standards set by individual retailers, put the onus on manufacturers to establish reliable product inspection programs. For over 20 years, food and pharmaceutical manufacturers have been using X-ray inspection technology to ensure product safety. X-ray systems provide unsurpassed detection of dense foreign bodies, including metal, glass, bone, mineral stone, and high-density plastics and rubber, irrespective of their size, shape, or location within a product or the type of packaging. By exploiting simple density differences and analyzing the resulting grayscale X-ray images, X-ray inspection equipment has moved beyond product safety into other areas of quality control. In a single pass at high-line speeds, X-ray systems can help manufacturers maximize overall line efficiency by simultaneously measuring product length, width, area, and volume, identifying missing or damaged items, monitoring fill levels, measuring mass, and inspecting for compromised seals. Measurement of the length, width, area, and volume of a product is the simplest form of product inspection used in conjunction with contamination detection. An X-ray image is a grayscale image, and the darker the gray, the more product is in the path of the X-ray beam. By converting those gray tones into a 3D image, the software can calculate the area of the product. X-ray inspection systems are capable of identifying products that don't look right, even if they're the correct weight, in the correct position, and contaminant-free. For this reason, they're indispensable for manufacturers of products that depend on visual appeal. For example, one of the 3 meat patties shown in Figure 1 has a hole in it, which shows up as a light patch amid the uniform gray. In Figure 2, you can see that one of the 3 patties is misshapen. X-ray inspection systems are capable of looking inside final sealed packaging and checking that all components are present. They are also able to inspect multi-layered packages and locate the missing items in the layers with ease. For example, they can count needles and syringes in a box, check for the locking lever in an asthma inhaler, count cheese cubes in a tray, or pralines in a gift box. For example, spotting the missing sausage in the figure below, animation of Figure 1 sausage, was easy. The software found 5 dark zones in the grayscale X-ray image when it was programmed to expect 6. Another common application is checking whether a cap or lid is present. Spotting the presence of caps or lids could be done by human eye, but the process is much quicker and far more reliable with X-ray technology. If the cap's missing, the cap area appears brighter on the X-ray image, and the product will be rejected from the production line. X-ray systems are also capable of detecting damaged items, such as crushed, missing, and partial tablets in a blister pack or dented, squashed, or deformed packaging. The detection of damaged products relies on the same principles as length and volume measurement. By setting the minimum and maximum sizes for pack width, height, volume, or surface area, X-ray analysis software can spot a deformed pack. In this image, a check for surface area was enough to catch a deformed carton of soup and reject it from the production line. As well as identifying objects that shouldn't be in a pack, X-ray inspection can find objects that should be there, such as instruction leaflets and promotional giveaways. Figure 1 shows a box of contact lenses which, according to industry regulations, must include handling guidelines and product information. By checking the leaflets in place, X-ray inspection verifies compliance. Figure 2 shows an X-ray image of a cereal carton containing a toy. If the software can find the toy, it's a good pack. At the same time, X-ray inspection can inspect for contaminants. By eliminating the toy from the image, the X-ray system can check the rest of the pack. It's a simultaneous process in which the promotional giveaway doesn't interfere with contamination detection. X-ray systems are capable of exerting better quality control by measuring overall and zoned mass. By converting gray tones into a 3D image, X-ray software can calculate how much product is in the pack. Systems have an auto-learn facility whereby an acceptable weight pack is passed through the X-ray system and an acceptable tolerance is established for the product. The X-ray system will then compare all future products against its ideal reference product. If the calculated mass falls within a programmed tolerance, the package is good, but if it deviates, the package will be rejected. Figure 1 shows a box containing 6 foil-wrapped cereal bars packed in 2 layers. The middle cereal bar is missing from the upper layer, causing another cereal bar to move out of place. It shows as shadows outside the normal range on the grayscale X-ray image and means the product will be rejected. The quantity of jam inside a donut is another example of how X-ray inspection can be used to measure mass. From the outside, a donut with too much or too little jam in the center looks perfect. No one knows until they take a bite. Too much jam increases production costs, while too little jam leads to consumer disappointment. With X-ray inspection, every single donut can be checked. Zoned mass measurement. For products presented in defined compartments, such as a box of chocolates or a twin-compartment ready meal, mass measurement can provide results for each individual zone. In this image, the overall weight is right, but there is low fill in the rice compartment, meaning the pack will be rejected. Maintaining the correct fill level of a product is a constant challenge in food, beverage, and pharmaceutical manufacturing. Overfills and underfills have an effect on costs as well as consumer satisfaction. Fill level inspection is different to mass measurement. It's a 2D process. X-ray systems allow manufacturers to set minimum and maximum fill levels and reject products that fall outside these. Fill levels can also be adjusted by adding an optional feedback to the filling machine, something which is especially beneficial for liquid foods and beverages, such as yogurt drinks or loose products like milk powder. In Figure 2, the stack of crisps has collapsed on its side and some crisps are broken. By checking the height of the stack, X-ray analysis can tell that the fill level has dropped below an acceptable standard and will consequently reject the pack. Zoned fill level inspection X-ray inspection is as good at checking zoned fill levels as it is at checking zoned mass measurements. An underfill in one pot of a yogurt multipack could potentially be compensated by an overfill in another pot. X-ray inspection is capable of examining the fill level in each pot, and if any pot is underfilled, it will reject the entire pack. The integrity of airtight seals is a vital quality control issue for food and pharmaceutical manufacturers. The safety and sterility of pharmaceutical products and freshness of food products depends on their seals, but they're easily compromised by stray particles of product, physical contaminants, or misplaced products. X-ray systems are capable of identifying particles as small as 1 millimeter caught in the seals. Figure 1 shows the X-ray image of a sealed pack of chocolate. The system checks for the presence of dense material between the inner and outer edges of the seal. If it detects material in this area, it will reject the product. An example from the pharmaceutical industry is the inspection of surgical wound dressings. See Figure 2. Here, analytical software will check that no wound dressings are trapped within the seal, thereby compromising pack sterility. Before we go, let's take a few moments to sum up. X-ray inspection equipment gives manufacturers the tools to maintain quality control and product integrity at every stage of production for raw, bulk, pumped, and packaged products. By setting appropriate parameters and fine-tune the sensitivity, manufacturers can investigate numerous quality issues from catching contaminants to measuring product mass, counting components, checking fill levels, identifying faulty products, inspecting seal quality, and spotting missing giveaways. The product that successfully passes X-ray inspection contains no shocks, surprises, or disappointments. The manufacturer knows it fulfills its brand promise. In short, X-ray inspection is a highly effective tool for maintaining production costs and product integrity. Most of all, it's a tool for keeping customers happy, for checking that a product looks and performs exactly as expected. Thank you, and if you'd like to stay up to date with the latest product inspection trends, just follow us on social media. Connect with us on LinkedIn, follow us on Twitter @EagleXray, follow us on Google+, and subscribe to our YouTube channel.